Welcome to Web Scraping with Python,
Damn, son, where'd you find this?
an online lecture for the Programming for Cultural Heritage class at the Pratt Information School. To cover web scraping, we're going to start off looking at why and when you should web scrape, and then we're going to move on to web scraping using Python. So first off, what is web scraping? It's basically when you're extracting structured data from an HTML page when you have no other data option available to you. So HTML is a structured markup language, but it's not as structured as something like a CSV file or a JSON file. It's still pretty kind of document based. So you can use web scraping to extract very structured data from an HTML document, which is a website. But most importantly, you need to know when you should web scrape and when it's not needed. So to understand that better, we can look at kind of like how web pages are delivered to you or how web pages are served to you. So if we look at this kind of common example of what a web page website is that usually there's a server sending you HTML files, and that server is powered by a database. So there's some information in a database. It's like a catalog, and it's being sent that it's being compiled and sent that compiled into HTML and being sent over to you in your web browser. So this is like a very basic kind of example of what a web page is or a website is. Sometimes, though, a website is not only just having serving HTML files to your browser, it also is serving you JSON files. So this happens when there is an API available for a website or a service. So if there's an API available, it's already giving you structured data, so you wouldn't really need to web scrape a site like this because there's an API available to you to begin working with their data already. Another example where you might see is that there could be an API, but it's not really publicized. So oftentimes, very heavily JavaScript-based web pages use an internal API to power those web pages. So you can actually see if a web page is making use of an API that might not be documented or published, but you can actually use it yourself to get access to the data that you wanted to use. And then finally, this is kind of like the best case scenario is that there is a server with an API, but also they're doing a data dump or a data export. And so if you have the entire contents of their database or kind of a slice of it that you're interested in, then there's no reason to web scrape at all or even use their API. You can just work with their bulk data download directly. So it's really important to know when you need to do this web scraping if you want to get access to the pieces of data you're looking for. So you only need to web scrape if the information you want is only available in HTML pages, right? So there's no API to use. There's no bulk download. There's no kind of non-public API version of it. There's no way to get access to the structured data without parsing their HTML pages and pulling the data out. And so really you can kind of think of web scraping as kind of like a last resort type of thing. You want to get access to this data set to use for a project or something like that, but it's locked up in a web page, and there's no other way of getting access to it. So of course you need to be kind of wary of legal concerns when you're web scraping. If it's a public website, it's pretty. There's been cases around it being perfectly legal to do kind of automated extraction of data on it. But of course you need to be wary of any kind of legal concerns around web scraping. In our examples, we're going to be using some cultural heritage sites, and they're basically kind of for educational purposes. But even with that, you want to be polite when you're interacting with other people's servers programmatically, because if you're on a web browser, that's kind of human-based interaction speed. But if you're writing a Python script, it can go as fast as your computer and internet connection can go. So you want to do things like don't request stuff so quickly. If you can kind of cache the data, which means kind of store it locally when you can, do that. Try to put some timeouts or some waits in between requests. Just try to be a little bit polite when you're using a script to access a web page. And so basically our high-level workflow is going to be kind of three steps. First, we're going to request the HTML pages from the website that we want. We're going to parse those HTML pages into a Python data structure. And then we want to do something with that data, right? So we'll probably do something like write it out to a JSON file or write it out to a CSV file for later use. To get started, though, we're going to be using two different libraries that are not built into Python. So, for example, like the CSV module is built into Python, so we don't need to install anything, or the regular expression module that you use to use regular expressions is built into Python. It comes shipped with Python, so you don't need to install it. But to do the two things that we want to do for web scraping, which is interact with websites on the internet, and then also parse those websites, we're going to install two libraries that make that functionality a little bit easier for us. So we're going to be installing requests for retrieving and interacting with HTML sites or web pages to retrieve the HTML. And then we're going to be using Beautiful Soup, which parses the HTML structure, and you can extract data and search within it. So you want to make sure that you have these two libraries installed by doing pip3 install requests for the request library and pip3 install Beautiful Soup 4 for the Beautiful Soup library. So to do that, you just need to open up a Python or a terminal window, and you just need to run the pip3 install command to install these libraries. So if you install Python from the website python.org, this application pip3 would automatically be installed on your system, and then you just need to run these two commands: pip3 install requests and pip3 install Beautiful Soup 4. And so I have these installed already, so it says, requirements already satisfied, but you should see a positive message like this letting you know that it's been installed. So our workflow is going to look mostly like these 4 steps. We're going to request the text of the page. So when I say text, this means the HTML of the page that we want to scrape. We're going to parse, and we're going to make that request and retrieve the HTML using the request library. We're going to parse the text or the HTML of the page using the Beautiful Soup library. And then we're going to use the Beautiful Soup library to look for specific features that we want to pull out of the website. And then once Beautiful Soup returns that data, we're going to do something with it. We're going to work with that data. So the kind of gotchas when you're doing web scraping is you really, in the modern kind of websites are very kind of JavaScript dependent, or there's a lot of JavaScript usually involved with websites. So what you want to do is make sure that the HTML is actually really there, because the way that the web scraping works is that your script is kind of like a little mini web browser, right? It's requesting the HTML from the server is sending you the HTML, and it's in the script. And so for the difference is that your script is not a web browser, right? So it does not do things like execute JavaScript or do all those kind of fancy client-side things. So in order for your Python script to actually access the data that you want, you have to make sure that the data you're looking for is actually really in the HTML itself and not kind of loaded asynchronously via JavaScript or some other sort of kind of modern web kind of JavaScript based website. And so I'll show an example of that, but you also will need to inspect the web page structure itself to figure out how the web page has been put together, and then understand what pieces and what patterns you can devise to pull it apart and get pieces of the data that you're looking for out of it. So let's look at a couple examples of what I mean when I say, is the data really there? Is the HTML really there? So in this case, this first example we're going to look at is a pretty basic, kind of straightforward website. Um, I just randomly picked a cultural heritage site. So here we're looking at the Detroit Institute of Arts site, and this is just their search collection page. And so you can see that there's resources here. There's many pages of resources, and so what you can kind of think of what the Python script is going to see is if you right click on the page and say View Source. And so this is the text that the Python page script is going to request and receive. And so when I say you want to make sure the HTML is really there, is that, okay, I'm going to see this self-portrait. I would want to make sure that this piece of data is actually in the HTML source. And you can see that it is there. So otherwise, you can imagine that maybe this site was put together using a lot of JavaScript. So this was not actually in the HTML code. It was actually created by a JavaScript kind of routine and injected into the website on the client side. So you just want to make sure that the data is actually present in the HTML source because this is what your web scraping script is going to see. It's not going to see the result of any sort of JavaScript or any other kind of client-side manipulations of the HTML. So that's what I mean when I say you want to make sure it's actually there. To give an example of a site that when the HTML is not actually representing the website, so what's in the HTML is not actually there, we can kind of look at this other cultural heritage site, Museum of Fine Arts Houston, and as we scroll down, we can see that it's a similar collection page as the previous site, but these results are being dynamically generated, right? As I scroll, the JavaScript is seeing that, okay, you're at the end of the page, I'm going to load more results. So if I looked at this source code of this, looking for this one piece of work, I wouldn't find it, right? Because this is not actually in the HTML. The HTML only has a very few first number of resources listed. All these additional resources that have been loaded asynchronously via JavaScript are not actually in the HTML. So if you actually requested this page via your Python script, you wouldn't see all these bottom images or these bottom resources because they're not loaded. They're not in the HTML. They've been loaded by the JavaScript and inserted dynamically. So in that case, you could kind of you have two options here, right? You'd have to kind of figure out how the website works, and so what we're going to be using a lot in this video is the developers tools. So if you're using Chrome or Firefox, you can access these developers tools. Um, and what they do is they give you a number of options to work with. But one of the tabs is the network tab, and so you can reload this page, and it shows you all the network activity that's done to generate this web page. So all the image assets, all the HTML, all the CSS assets, etc. So what you can also do is there's this tab called XHR, which shows you kind of the asynchronous activity of the site. And so if we reload this and we scroll down, we can see as we start to get to the bottom of the page, it's making these additional requests. So this is an example of the option of the API option where there's this kind of like a secret or non-public API that's powering the page, right? It wasn't developed to serve kind of like a general audience. It was developed just to allow some functionality of the site to work, right? So this dynamically loading of images at the bottom of the page instead of this endless scroll of images as opposed to pagination. And so there's an API powering this, but it's not meant for public consumption, and it's just meant for the website to use. But that doesn't mean you can kind of figure out how it's being used and then use that to pull data out of it as opposed to web scraping. So that's what I mean when a non-public API. So of course, before you start developing a lot of web scraping things, you'd want to make sure these kind of three options are exhausted before you start looking at scraping the HTML. So you'd want to make sure that there's no public API available, that there's no kind of like hidden API available, and that there's no like bulk download available for you to use. So for example, if I wanted to, I was really interested in the Metropolitan Museum of Art in New York's collection, I would just do a simple search first, right? A Google search, be like, is there a Met API? And it looks like there is, right? So I'd go through here and find out how to use their API, because it's going to be much, much easier to access their API and process their data using their API than try to figure out how to scrape their website. So always look for that. And then, of course, the Met also has a bulk download in their GitHub. So you'd want to, you might even rather use that than use their API. So always look for alternatives and then start thinking about how you would web scrape as kind of like a last resort. Let's try scraping the Milwaukee Art Museum collection here. First thing we need to do is really kind of figure out how the website works, right? Because if you think about how a website set up, it's pretty much a reflection, in this case, of a database. So you have a number of resources or items in the database. You have an index to those resources and items that allows you to search or browse them. And then you have individual records about each one of those resources or items. So in this case, you have various resources grouped together in collections, and if you click through into one of the collections, you see a list of all the individual items or resources for that grouping. So you really need to understand how the website's kind of like assembled or put together if you wanted to kind of scrape it or access the individual items or records. So if we look at this search page or search functionality, you can click go, and it dumps you into this search page result, and it shows you that you have, 9,000 results, and there's 10 results per page, so there's 950 pages. And so you can kind of think of needing to do two things, right? You could look through each one of these pages to get each item that's in the database. And then if you wanted more data than what's provided on the search result page, you'd have to go into each one of the items themselves to pull out the metadata. For example, if you wanted more detailed metadata about this work, for example, something like the dimensions of the work, you would need to actually go to the specific page itself to pull out that information because it's not provided on the index. But you won't even know what um, items are in the database unless you have this index available to you to look at. So what we're going to do is we can kind of take a two-step approach, right? So the first thing we want to do is basically pull out all the links to these different items, and then potentially we might want to go through and make an additional 9,000 requests for each individual item that we're interested in. So of course, it's not really if you're not interested in the entire collection, right? Because you probably have something specific you're interested in, you can leverage the website to help you narrow down the things you're looking for instead of having to scrape the entire site, right? So if you're just interested in decorative arts, then you can use the website to build a URL that just returns decorative arts materials. So in this case, it appends a number of parameters to the URL, and then once we have that, our set is much more narrower than it would be before, right? We don't have to do 100 pages around as opposed to 900 pages. So definitely use the site to help you understand or to help you kind of narrow your search criteria down to what you're just what you're looking for. So in our example, we're going to just kind of do something more general. We're just going to try to scrape a few pages of the site just to get some experience, and we're not going to narrow it down based on any of these filters yet. So what we need to do is first, before we start writing the Python, is to see if it's even possible, like via the HTML, how it's structured to pull out this information that we're interested in. So in your browser, if you right click and you say inspect, this will pull up the developer's tools and highlight specifically the piece of the document or the element that you're hovering on or selecting. And so you can see that even if you're not too familiar with HTML and syntax, that there's a number of elements on this page that holds the metadata that we're interested in. And so what we can do is start to think about, what would be our strategy for accessing this information? What are some like natural language kind of statements we can make to plan a strategy to get access to this information? So for example, we could see that each one of these pieces or each one of these works of arts are in its own div element, right? And then each one of those div elements has a class called object work. And so you can make the statement, okay, I want to find all the divs on the page that have the object work class. And then that would allow me to pull back all the artworks on the page, or at least this section of the page that contains the link to the artwork, right? And so if we expand it even further, we can see that, okay, then there's the URL to the artwork, item page itself. If we wanted to do that second pass to pull out more information we could use. And then it has this unordered list element with a credit class, and it has in it the title of the work, or I'm sorry, the author of the work or creator, and then it has a link with the title of the work with a link to the item page. So you could kind of see from this HTML setup that there is indeed enough kind of nuance to the HTML that we could think of some strategies to actually pull out the information that we wanted. So let's get started and try to scrape this search result page for a few pages. So I'm going to make a new Python file in my text editor. So I'm just going to create a new file and save it first. So I'm going to save it as in my downloads. So I'm just going to save it there temporarily. That's where I'm going to run the script. So we'll call this web scrape .py. And the first thing we need to do, as I mentioned earlier, is that we're going to be using these modules to add this additional functionality to our script. So we needed a module to interact with the internet, so to actually request the contents of web pages, and then we needed a module to parse those web pages into something we can work with. So the first thing we're going to do is import requests. So this is the module that we're using to interact with the internet, with web pages, and to pull back information. And then I mentioned the second thing we're going to do is import Beautiful Soup. And the way we do that is with this import statement. We're going to say from BS4 import Beautiful Soup. So Beautiful Soup is going to be the name of our variable that we're going to use to access the module, and request is the name of the module that we're going to, or the variable we're going to use to access that module. So I'm just going to save it now and open up a new terminal and move to my downloads directory, which I am already. And I'm just going to try to run the script to make sure it works. And so nothing happens, but we didn't get an error message, so we know that we installed the request module correctly, and we installed the Beautiful Soup module correctly. So we're off to a good start there. So to interact with these pages, we need to use the request module to actually request the data, and then we can use the Beautiful Soup to parse it. So to request the data, we're going to make a request using the request module. And so we need to define where we're going to request, or what URL we're going to request. So this is make a new variable called URL. And in this variable, we're just going to say the address that we want to use to scrape. And so we can just come up here and use this collections URL that we are on. If we wanted to filter it first, that would be the URL that we use. But since we're just going to do the entire collection, we're going to use this address. So that will just be the starting point we're going to start with. And then we need to use requests to actually make that, to retrieve that HTML. So to do that, we say make a new variable. We'll call this the page request results. And we'll say requests.get, and then the URL that we want to use, which is stored in our URL variable. Right, so when you interact with the web, there's various verbs you can use, right? You can get, you can post, you can put, you can delete. For our web scraping, we're mostly going to be doing gets, so that's the method that's built in to do the get request. And so that's going to store the results in this variable, and then inside of this variable, there's going to be a piece of data, which is the HTML itself, right? There's other stuff in there like, the status code of the request, that it was successful, did it fail, if there was an error message, etc. But what we can do is we can just pull out the HTML that we got back. So we can say page HTML equals results dot text. Text is whatever came back from the server, whatever response was in the body of the server response. And so let's just try to print that and see what it looks like. All right, so if we run this again, we see a bunch of HTML elements, which is good, right? So this means that the request module made the request successfully, it returned HTML, and then we can print it out. And so if we look through here long enough, we could probably start seeing that structure that we saw in the inspect in the web browser, right? So here's the object work div that has the credit in it, and then here's the name of the work or the creator, and then also the name of the artwork title, and then there's also the URL to the artwork itself. So we know it works, right? So we're able to actually get access to that HTML programmatically in our Python script. So now that we have it retrieved from the internet or from the website, the next step that we're going to do is parse it with Beautiful Soup. So now that we have the data downloaded from the website, we want to parse it using Beautiful Soup. To do that, we're going to just run it through the Beautiful Soup module that we've imported, and we're going to store the result in a variable. So we'll say soup equals Beautiful Soup, and then in there we pass the HTML of the page, and then we also need to pass, we have to tell Beautiful Soup what parser it should use, because HTML is basically an XML type language, and so it could parse it using many different libraries, and we're just going to tell it to parse it using this HTML parser library. And so it's going to store the results of that in the soup, and then we can try printing it just to see if it works, and we'll see how it looks. So let's run it again. Right. And so it didn't give us any errors, and it printed out the HTML because when you ask Python to print a Beautiful Soup object, it will try to turn it into a string. So it turned it back into its HTML. So, but what's nice now is that we have it not parsed. We don't have it as a text as we did before. We have it parsed as a Beautiful Soup object. So this Beautiful Soup object is actually kind of really complicated, and it has a lot of things built into it that you can do. So for example, it has the find method built into it. So what you can do is find all the instances of a certain type of element. So you could say find all, and then pass what element you're looking for. So in this case, we're looking for the divs. First example, you could look for a elements or spans or anything like that. And let's just store this in a variable called all divs. And so the soup module or Beautiful Soup will parse this HTML, and then you can do these kind of queries on it and return the results. So let's print out the results of this query for all the divs. Right, and so now it will return the results as a list, and a list of all the divs and the contents inside of there. So you can see it ends in the square bracket, so we know it's a list. And here's the first one, then another one, and the contents, another one, etc., etc. And of course, you could do all the things you can normally do with a list of things. You can loop through it, right? So you could say for a div in all divs, print a div. And let's print another line here, like a dividing line, just to show the separation between them. So it went through each one and it printed out each div that I found in the HTML page. And of course there's nested divs inside of each other, so it went through each one and printed out all of them. So that shows that we can access the individual elements based on their element name, right? So the div. But for us, we need to be a little bit more specific, right? We need to be able to construct one of our strategies for finding what we want and translate that into Beautiful Soup syntax. So if we go back to the web page again, we discussed earlier that we want to get access to each one of these pieces of metadata, right? And so what we said is that by inspecting the page and looking at each one of these, we saw that there's each div is in here and it has a class of object work. So we could think about using that as our initial kind of entry into the page to pull out the data. So let's go back to our script, and what we need to do is modify this find all method to not just find all the divs, but something more specific. So we can say find all of the divs where the attributes have the class object work. And over here, we're passing this second argument to the method to say, okay, wherever there is a class and the value is object work, limit the divs that you find to those only. And so if we save that and try to run it again, we're now only returning those object work divs instead of everything in the page, all the divs in the page. So we can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Because there's 10 objects per page. All right, so now that we have narrowed down to the specific div that we want, we're getting close, but we still need to go in further and look at the individual metadata inside that div, right? So if we look at this object work div, we see that there is a creator tag, right? So that lives underneath of this class credit. So it has the creator, and then it also has the title and the link to the um, specific item page for that individual item. And so we can kind of break this down into natural language and say, okay, so, and we can also see there's a link here that has the same link to the item page because it also has the image. So the image, for the image to be clickable, it's inside of the same kind of a link tag. So if we want to get access to these two items in here, though, we can say, okay, so there is this um, unordered list named credit, and it's actually the only unordered list in the div. And then there are two list elements, the first of which contains the um, creator, and then the second one contains the link and the date information. So say we want to pull out the title or the creator, and then the title and the link, and that's kind of what we're only interested in for this situation, because then we're going to assume maybe we're going to go back and pull in full metadata for the rest of the items on the site by the individual item page. So what we can do is say, okay, now I want to look for the UL element underneath of this div, and then the two LI elements, right? And so what's really cool about Beautiful Soup is that every time you do one of these queries, it returns another Beautiful Soup object. And because it's a Beautiful Soup object, it has these find and find all methods built into them. And so you can do another search based on the result of your first search. So you can actually do a new Beautiful Soup query based on this a div, which is one of the divs that was returned from that big search in the beginning. So, for example, we could say, okay, let's find um, all the LI elements in this div, right? Because there's only going to be LI elements that contain the data that we're interested in. So we could say, okay, let's do a search to find all those LI elements. So all LI elements in div. These are very verbose named variables, but you get the idea. We can say find all and just look for the list elements, because we don't care about narrowing it down at all, because those are the only elements that are LI elements inside of this div element, which we're limiting our query to because we're using this result of the first search to query in. So let's try printing those out. Right. So it returned a list of all the LI elements just in that one div that was returned from the original query. So we can see here, this is the first one talking about the new, and the second one talking about the jug, and et cetera, et cetera. So let's look at this first one though, because there are multiple LI elements here. So we have a first one here, and then we have a second one, then we have a third one, etc. So let's see why it looks like that. So we were looking at this example here, but let's take a look at this one. So in this case, there is more than two li elements, right? There's actually a lot of li elements. So this one maybe is a title or additional creators, looks like, as opposed to, all the other ones where there's only, a couple li elements. All right. So what we can do is we need to kind of figure out an approach we want to do for these results. We could make two decisions here. We could say, we don't really care about the metadata provided here in these li elements because we're going to be making requests for for each individual page, or we could say that we do actually care about this as kind of like an initial piece of metadata that we want to pull out. So if we would have to kind of figure out a search strategy for this, right? So we could kind of assume that, okay, for all the li elements until the last one is going to be information about the creators, and then the last li element is going to be the title. So you'd have to go through many of these item page results and make sure that that kind of strategy holds up against the rest of the results that you might be looking at. So let's just look at one of these. So in our strategy, we're saying all the li elements before the last one are the creator statements, and then the last one is going to be the link with the title name and then some date information if it's there. So from a kind of quickly limited look, it looks like that's mostly true. So we want to develop that in our Python code to take advantage of that assumption. So we have all the li elements here. So we want to separate all the li elements, all the ones in the beginning versus the last one, right? And so what we can do is we can make ranges using the lists, because lists you can define specific ranges. So we could say, create a new variable called creator statements, and say, okay, that's going to be all these li elements that starts from 0 into the last one, which is -1. So let's print that out and see if that's true, if we got our range correct. All right. So we just wanted to make sure that it's only printing the li elements that were all of them except the last one, right? So in this example, we know that there's two and that it only prints the first one. In this other example, the first one has many of them, but it doesn't print the last one, which has the title and then the link to the item. So we know this is working, right? This is just the creator statements. And so what we could do is make a new list called creators. We'll make it an empty list. And we can loop through all the creator statements. Remember, these are the li elements. It might make sense to call them li, right? Just to make sure we remember what they are. And so what we can say is for li elements in, so now each one of these are the initial li elements, and we could try printing them out, right? So we see here all the various li elements. And so in this case, it's still a beautiful soup object, right? It's still this kind of internal beautiful soup element, because you can see the HTML tags in it. But what we want to do is get the text out, right? And so what beautiful soup provides is this text attribute. And so text only returns what's inside of the element, not the whole element itself, right? So now we're just dealing with text here. We're not dealing with beautiful soup, elements and all that sort of thing. So what we can do is we can just add these to the creators list, right? So creators.append, It's a list, it has an append method, and instead of printing that, let's just append it to the list. So now it's going to loop through each one of those creator statements and append it to the list, and then we can just print them out at the end here and just to make sure it's working. We should have a list of strings now, right, with all the creator statements. Right, because you could kind of mush these all together into one big string, but it's important to keep them separated because you might want to do something with them in a separate kind of each individual basis later on and not have to deal with parsing them apart again. All right, so that takes care of the creators, so those were the beginning li elements. And what we can do now is we're just interested in the last one, right? So that took care of all of these. And now we're just interested in this last piece, which contains the link to the item and then the title of the work itself. Because we know that we're going to be dealing with the last one, we can actually just quickly pull that one out. So let's make a new variable called title li, and we can specify, as we specified a range here, we can say, okay, we don't want to specify a range, we just want it to be the last one in the list, right? By using -1. -1 means in a list, the last one. And so in this case, if we printed out each one of these, we would expect to see the title statement for each one. So there's title, 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 right? And of course this date information as well. So if we look how this is structured, there is a list element that we now pulled out. And inside of there, there's a I, which is like kind of a italic. It's a kind of depreciated italic HTML element. And there's two of those, right? Oh no, there's one of those. So there's the italic element, which is the title, which contains the A element, which is the link, and then the rest of the text is the date information. So what we can do is we are interested in two things here, right? We're interested in the name of the work, and then we're interested in the link, the URL to the item page. So to get the name of the work, right, we want to find it lives inside of the A element, right? So because this is a beautiful soup object, even this li element has these methods built in, these find and find all methods built in. So what we can do is say, okay, say a link equals title li find, and we want to find the a element. So in this case, we're not doing the find all, right? We're just doing find because we don't want to find all of them. We just want to find the first one, and there's only one. So we're going to do find. So let's print that out. So here it's just pulling out the individual A link, the link element to the item page, and then the name of the work, right? So let's make these two different pieces of information. So we want to get the title. It's going to be the text, right? We talked about that earlier. And then this is going to be new. The link is going to be the attribute, right? So the attributes are these things like href. They live inside the element. And to access the attribute is you just treat the beautiful soup object like it's a dictionary. So you can say link equals a link, and then inside of here you put the attribute you want to reference. So in our case, it's href. So let's print these two things, just the title as a string, right? It's not an element anymore, and the URL. Right, so I printed out the title and then also the URL. So one thing that we might want to do initially is notice this URL is not there's no HTTP, www, whatever.com or org. right? It's just this details.php ID equals number, number, number. So this is what's called a relative URL because it's assuming you're on the web page and it's going to use whatever URL is currently on the web page and link it to that. So you'll notice in the bottom left corner there, it's building the full URL, but inside the HTML itself, it's actually just kind of a relative URL. So to save us some trouble later, let's make this a full URL. So we know that if you click through, it's going to add this additional prefix to this piece, right? So we have access to this piece in the HTML. This is the full part of the URL. So let's copy that and just make the URL complete right now. So since this is just a string, right, we can add two strings together. So we're going to add this first prefix to it and then add the rest of it, right? So if you run it again, you should see the title, and then now it's a full URL. All right, so we have the title, we have the link, and that's all that we were interested in working with. So we have that for each one, right? So we have the creators, the title, and the link. What we want to do now is do something with it, right? So it's fine to be printing this to the screen, but it's really not useful for us later, right? It's not, we're not doing anything with it yet. So what we could do is make a new place of storing this later, right? So we want to output this somewhere and work with it later. So what we can do is say, we want to save this as a JSON file so we can come back and load it up later and do something with it. So for example, say we're going to write two scripts. This first script is going to pull out all the titles and creators and links, and then maybe we'll write another script that's going to actually go to each one of those individual pages and add the rest of the metadata that's on the individual pages and not on the search result page. So to do that, if we're going to write two scripts, we need to communicate the data between them. So for the first one, we need to have some place to store it. So if we had like a database or something like that, we could store it in the database. But since this is not very complicated, we could just store this as a file on our system, right? So let's store this as a JSON file. And so if we're going to work with JSON, we know we need to import the JSON module. And so if we're going to save all this information that we've been printing out, we need some place to put it. We need to store it in a Python data object so we can convert that to JSON and save that to our local system. So let's make a place to store all this data, right? So if we're going to be storing all this data, we'll just call it all data. And then we want to store this data. There's going to be many of them, right? So it's not going to be a string. It's not going to be a number. It's not going to be a dictionary, right? It's going to be a list because we have many pieces of data that we want to store. And so what we can do inside of the loop, right? So inside of here, we're looping through um, each one of the divs. So that means each artwork, right? And so what we can do is make a new empty data structure to store all these pieces of data that we've just been printing to the screen so far. So we can say, let's make one called artwork. And if we think about how this data should be stored, yeah, there's going to be many pieces of data, right? But it's going to be more of like a key value kind of pairing. We're going to say, okay, we have the creators, we have the title, and then we have the link, right? So when we're dealing with that kind of key value pair, we want to have a dictionary, a Python dictionary. And so when you have a Python dictionary, you can define stuff up front, right? So you could say creators and then equals whatever, or you can define it as you go. So we have creators here, we have title, and we have link. So what we could do at the end is move this to the end and define it here. So we could say, okay, creators is going to be equal to the variable creators, We're going to put a comma because there's going to be another one. We're going to say that the title is going to be equal to the title variable. And then we're saying link here, but let's call it URL here. It's going to be the URL here, link. So that's one way of doing it. Another way of doing it would have been defining an empty artwork up here. So empty dictionary up here. And then instead of storing this information here, you could do something like this. You could say inline, and then inline add it to it. So these are the same ways of doing it. This is a little bit more confusing maybe. So if you wanted to keep everything kind of very clear and have its own variable, let's just do it this way, where we're creating this dictionary at the very end of our data. So each individual element stored in its own variable, and then we're creating this artwork variable at the end. And the last thing to do is kick it into our big data bucket here, right? So we'll say all data, and this is a list, so we can say append, and then the piece of data we want to append is this current artwork, right? So for each loop, so each work of art is going to loop through here. It's going to loop through here, and it's going to make a new artwork on each iteration. So it's going to overwrite the data that was, it's a brand new blank slate, and add it to this dictionary. So artwork's not going to persist because this is inside of this loop. So for every loop is going to be released, but all data is going to persist across all the loops, right? Because it's outside of the loop. It's above it. So at the very end, let's comment this out. At the very end, let's print out all data, see what it looks like. So if we see here, we can look at that there is a list of dictionaries, right? And each dictionary has a creator key, a title key, and a URL key. And then that just repeats for each one. And then the last piece we want to do is actually write this out to a file for later, right? So we learned before that you can use the JSON module, and you can say dump. So dump S is for a string, but dump with no S is just for a file. And you have to pass a couple parameters. The first one is, well, what variable do you want to dump? And so we want to dump all data. Then it's going to say, okay, where do you want to dump this? And you have to open a pointer to a file on your system. So we'll call it artworks JSON. Remember, we need to say open that as write, so we pass a W. And then there's a kind of a nice feature that JSON has called indent. The indent argument. You can just say, okay, can you indent this for me by 2 white spaces? Can you pretty print this for me so it looks a little bit better? So instead of printing it out, let's do this. So this should run. Nothing happens, but if we look for that file we just created called artworks, you can see it's there. Let's see how big it is. It's 2.4 kilobytes. And on my system, I can say open artworks. We'll open it up in a text editor that I've defined. So here it is. So it's taken all of that data from the website and turned it into a JSON dictionary, and then added each one of those dictionaries to a big list. So we've basically gone from an unstructured web page to a JSON file with this information. So the last thing we probably want to do though is, if we go back to the web page and look at it, we scraped the first page, right? Let's go back. So we were on this page, right? And it's just the first page. What we'd really want to do is scrape all these pages, right? Say that was our goal. If we wanted to do that, we'd want to scrape all of them. So what we're going to do is we need some way to loop through all 950 pages, right? And we know there's 950 pages because the website's telling us, right? So if we look at these various pages, if you start off on page 1, we can see the URL change. and it changed to add this question mark, which means that it's going to pass arguments, and it's going to pass this s equals 0, and then type equals quick search, and then search equals nothing, right? So let's see if it works if we get rid of these additional pieces. Yes, it still works. Okay, so this is page 1. Let's go to page 2 and see how it looks. All right, so now s is equal to 10, right? So that makes sense, right? Because there's 10 things on the page. So it must be saying, okay, start at item number 10. And let's change this to see if it works still. Yep. All right, so we know that if we change this s variable to whatever number we want to start on, it will start off at that page or item number count and then, show the next 10. So we could do 500, right? And it would jump to whatever the page number it is for 500, which is 51. So we need to do a little bit of math here and say, like, okay, how many times would we want to loop through this to get to the last one, right? And if we jump, let's see if it does it for us. So if we do the last page, it goes to s equals 9,490. So how many times does 10 go into 9,490, right? Divided by 10 is 948. So we'd have to loop 949 times to get all the results on this page, right? So what we can do is now knowing that information, we can go back to our Python script and modify it to not only do this one page, right, but to do all of the pages just based on changing this one variable in the URL. So let's go back to our script. And here we're defining a URL, right? But we know our URL needs to look something like this with this s at the end. So we'll modify this one to say s equals something, right? Don't know yet what it's going to be. And let's have a item counter equals 0, right? And so what we can do is do a loop, right? So we want to loop for 949 times, and for each loop we want to add an item counter by 10. So that this is, first it's 0, then it's 10, then it's 20, all the way up to 9,400 or whatever it was. So what we can do is we can make a range of numbers and loop that many times. So we could say, okay, total loops equals a range of starting at 0 and go all the way up to 949. So I'm going to comment out all this stuff that we've done before just to show what this looks like, right? So let's print out this. Print it out and in the script. Okay, so it's a range. That's not very useful. Let's write a for loop. For x in total loops. So let's make sure it's doing what we thought it would do. So there's 0, and it's going all the way to 949, no, 948. So we want to change this to 950, right? Make sure it gets all the way to that last one. And so what this range function does is it makes a list, and in this case, the list is numbered, and it's 0 through 950, and not inclusive, right? So 949, but not 950. And so now we have a loop here that's doing this for us. So we could change x to be something more, makes more sense, right? Page count, page number, or something like that. We'll say total pages instead of total loops. Now that we have this, we have a mechanism for it to loop 949 times. And remember, the first thing we said we wanted it to do is make the item counter equal plus 10, right? So we'll say item counter equals item counter plus 10. But we want to make sure this happens last, right? Because the first time it runs, it needs to be 0. So this needs to happen at the end of the loop. And what we can do is we can take all that code that we were doing and move it inside of here. But if you think about that, we also have to move this stuff inside of there too, because we actually need to request the page 950 times and parse it 950 times and then look for all the divs 950 times. So I'm going to leave the total page range generator outside there, the loop, but inside the loop, I'm going to tab everything inside. And so now we have this URL and it ends in s equals something, but we need to build it into a real URL. So let's make our URL equal itself, right? And then we're going to add in page number. And if we ran this, we'd run into a problem because this is a number, not a string, and you can't add a string and a number together. So we're going to turn this into a string before we add it together. So let's comment this all out again and just make sure our URLs are working, right? Let's print out each URL. You can see here, it is going from 0 all the way to the last page. So if we picked one of these URLs and we visited it in our browser, it would work, right? It's just a normal URL. Yep, here's that page. So we know our URLs are working. So now that we can, during that, we could add in the rest of our code, right? So I'm going to uncomment this part, right? So it's still going to request the URL that's been modified. It's going to get the text. It's going to parse it through Beautiful Soup, and it's going to pull out all those divs. And then we need to move this stuff that we've been working on before inside of the loop as well. So now we have a loop inside of a loop, right? Nested loops. This is looping through all the pages, and then this one's looping through all the divs on each page, right? And we don't need to change anything here because it works as intended, right? Then the last thing we said before that we're going to add this item counter to the item counter to make it go up by 10 so that it's ready to do the next piece, the next page when it gets to the top of the loop again. So what we could do is uncomment this again, right? Because we want to save our data at the end. And you have to think about where you want to put this, right? So if you put this inside of the loop, it would happen each time, which you may not want, or you could put it at the end, outside the loop, so it only happens at the very end of it. I'm kind of testing it right now, so I'm going to put it on the inside of the loop. But if you were, ready and set, and you didn't need it to run every time, you might want to put it at the very end of the script outside of the loop, so it doesn't happen on each page. So in this case, though, it's going to happen on each page scrape. Every time it loads a page, it's going to load write out a new file of all the data. So let's make this little print statement a little bit nicer, and we'll say working on. And it'll put the URL there. That will kind of give us a little update of where it is in this process. All right, so let's give it a go and let's try it. All right, so this is a pretty polite script, right? This is like if you were on the page clicking next, 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 next. It's not anything too aggressive. But say maybe it was going extremely fast and you were uncomfortable with how quickly it was scraping the page. You could actually import a module called time, or time. And time has a method built in called sleep. And so you could say time.sleep. And inside of here, you say how many seconds you want to sleep. So let's add a 1 second delay between each loop, right? We'll put it at the very end. So now if you ran it, actually sleeping on each request, right? Because if you increase this to 10, it would sleep 10 seconds. And then after 10 seconds, it would go on to the next one. So oftentimes, if you're working with a web page, it might start kind of throwing errors if you're going too quickly. So this is a nice way to slow down your scrape. And so, if you're doing this overnight and you let it run overnight, it doesn't matter to you, right? If it sleeps 10 seconds between each request, because, in the morning it's still going to be done. You just have to run the math, right? To say like, okay, 950 times 10, how many seconds is that? How many minutes is that? To make sure that it's not, like days. Um, but you try to be as polite on the web server as possible. You don't want to overrun it. So we'll leave it at 1 second. All right, so let's run it again. And if we open that file again, you can see it reload each time, and it's getting longer and longer and longer, right? And we can go back and we could sit here and watch it, and it's kind of like a little robot scraping, each page one by one, kind of like a scraping robot. So after the script ran, we would have an entire JSON file full of the items. And so at this point, if you had this was all the data you're interested in, you could do something with that. But if you wanted to do something more, you might need to scrape each individual page, right? So then you would need to, we won't do this in this video, but you need to create a new script, right? So if we kind of just plan this out, what this would do, the first step would be open that JSON file and load the entries, loop through each entry, and download HTML page, parse each HTML page, and pull out additional metadata, add that metadata back into the JSON file, and resave it. Right, so this would be your second script, and these are the steps you would do that you would want to continue on with this process and pull out more metadata and enrich this original file with all that other metadata like dimensions, medium, all that stuff that you might be interested in. So that brings an end to this video. Until next time, bye.